39, and here's our formula for, what is it, 1/2 AB sine theta, right? Yeah, okay. That's it. Ooh, okay, that was close. 1/2 AB sine theta. Now what that allows you to do is, this is when you don't know the height, because remember, a formula of a triangle is half times base times height. Now you've got the b, but you don't have the height, so this is where the a and the sine theta come from. If you know the angle and you know another side, you can actually, you're basically solving for this, all right? So what do you got? You got theta here. So if this is theta, you've got, let's just call this A. Okay, so here's AB. And you need these guys to be on opposite sides here. Okay, so how did we figure that? How did they figure out 102? Because in order for this to work, the A and the B have to be on both sides, okay, of the angle. So that's, these guys have to surround this theta. So how did they get 102? Okay, let's see. Was it given? Is it given? I don't know if it was actually given. I feel like it has to be, because that would be a side angle. Otherwise, this would be a really long problem if you didn't know 102. Let's see. Let's actually see if you guys knew the 102. And the answer is you did not. Okay, you did not know the 102. So how did we figure out the 102? All right, well, you don't know if it's a 90, and that is a side angle. So a side angle means that you would have had to use, okay, would have had to use a law of sines to get this guy. Okay, so let's not call him, yeah, we'll call him x. So this means x over, nope, I'm sorry, my bad. 15 is the sine of x equals 15 over the sine of 39. Okay, so if you guys notice, this is an isosceles triangle, okay? So this has to be 39. So this is not nearly, and you can actually see right here, these two are equal. So the sine of, they'd have to equal each other. So that is 39. So you've got 180 minus 2 times 39. So that's how they get the 102. So isosceles triangle. And that's also another theorem. The arms or the legs of an isosceles triangle have equal base angles. Okay, now from there, it's easy. Then you've got the angle in between the two sides. You just use this formula. Half times A times B times the sine of 102. There you go. Here's Heron's formula. This, you're given a side. And then what you do is you essentially, to get the S value, remember the S value is a semi-perimeter. And what you do is you add everything you got. And you don't take the average, though. Okay? You actually divide by 2. So take, because it's like half the perimeter. That's why they call it a semi-perimeter. So you got to divide by 2. And that's going to be 28. 28 plus 8 is 36. Divide that by 2, and you will get 18. So that is our S. So then you go 18. 18 minus one leg, 18 minus the middle leg, 18 minus the last leg. Whatever that is, go ahead and punch that in. Take that square root. And that's the area. Okay, so this is Heron's formula. Okay. All right, these guys, if it's just basic sine, cool. These guys are a little bit more complicated. I was hoping that at least your study guide would land on the exact area, on the exact spots. I hope that's the case. We'll get there in a second. Right now, we're doing sine. He's negative, so negative sine will flow like this. Okay, so I always like to do the basic family sketch of a negative sine. Tangent, I know, is going to look like that. Okay. Cosecant is just going to be a loop like that. Same with him. And then cotangent always does that. So that is what I always like to do. And that actually, if you're talking about an SAT or anything, like that, you can now cut your chances down to 50-50. Okay. All right, so you got negative sine flows like this. I see a 4 there. So what that means then is that the period equals 2 pi over b. And in this case, b is 4. So that's how we're going to get 1 pi over 2. So this means that a sine cycle is going to happen half the distance, a quarter distance of 2 pi. So you're going to see that whole thing happen right in between there. So this is its full cycle right there. Okay? Full cycle. And there's nothing else going on. He goes up 1 and then down 1. Or I should say down 1 then up 1 because it is negative. All right, just execute the thing through all negative 2 pi all the way to positive pi. And then don't forget to put arrows. Tangent, you got an undefined amplitude because amplitudes don't work on tangent. That's not what he's about, okay? So what we got to do is find the period, and we know that tangent runs a different kind of thing. His period actually is pi. He goes from negative pi over 2 to positive pi over 2, okay? So that's how he runs, and he is going to, that is a 1 pi distance, so we're going to have pi over 2 over 3, which is 3 pi over 2, okay? So that's where he comes from. We're dividing by a already existing fraction. So this means 3 pi over 2 is going to basically be the distance, total distance spreading outwards. Okay, now normally we would just go to pi over 2 here and pi over 2 here. That's where tangent would normally sit. Okay, but we're going to have to extend it. So we've got to figure out how many units is 3 pi over 2. 3 pi over 2 goes all the way to here. Okay, there's 1 pi over 2. 2 pi over 2, 3 pi over 2. So he is 6 units, okay? So this means, starting from here, we're going to go 3 this way and 3 that way. That is a period of 3 pi over 2, okay? So once that is established, the 0, 0 part of tangent will go right in the middle. He's not going up or down, to the right or to the left, okay? Don't have any of that going. Okay, but what he's got, though, is when he moves over, he's got to go to exactly half of that distance from here to here, okay? And then he's going to go up 1, okay, normally. But because of the 2, it's not an amplitude, though, okay? But we are going to double that distance. We're going to go over a 1.5 because that is half the distance, and then he's going to go right there. Now, that is enough for you to see how much of a curve this guy needs to be, okay? Now this is one of the tougher ones, okay? Tangent and cotangent are one of the tougher ones, but remember they go outwards like this from the center, okay? That's how you want to look at it. These guys go from the center and then just march forward. This guy kind of goes this way, okay? The same thing's going to happen with cotangent. They're going to start, I think he starts right here, okay? And then he goes this way. All right, okay, so now we've got this guy. So we got a distance of 1 over 2, okay, or 1.5, and he doesn't have an amplitude, though, because he's secant. Secant is related to cosine. So we're going to have to graph this guy. We're going to graph this guy, and then we're going to just draw upward quadratics or hyperbolic curves from each of these points. I don't think technically it's a quadratic. But secant actually has the same period as cosine. So this would be 8 over 3. So then this would be 6 over 8. Oh, and so that would be 2 pi over 3. I'm sorry, 3 pi over 4. Okay, divide those by 2. 3 pi over 4, that's what we got. So we're going to go to 0, 0. Okay, and now we're going to go up 1.5. Okay, and we're going to go to 3 pi over 4. Now 3 pi over 4, this looks a little messy here, but there's pi, so 1, 2, 3. That is 3 pi over 4 right there, and that is where he begins his cycle again. And then right in the middle is where he goes to negative 1.5. So here's our cosine right here. Now every time this cosine hits the x-axis, that is where you're going to find a dotted line. So we are just going to go just like this. Okay. And graph this guy first. Graph this guy first, do it very faintly, and then be ready to erase it so that all the upper ones go up, all the lower ones go low. Okay? Wherever he hits 0, that's where the asymptote is. And that's all you got to do for secant. So if you can graph cosine, secant is just a nice little obvious extension. Now cosecant is related to sine, so he's going to do this. Okay? So then we don't have an amplitude though for cosecant either, because that's not an amplitude. But it kind of is for sine. So what we've got to do is graph sine first, and sine starts at 0, but we don't know the period yet. Let's take care of that. We got 2 pi over b, and the b actually is 2. So it looks like this happens over pi. So sine will do a full cycle from here to here. Okay? And then sine does this. He goes up 3, down 3. He would look like that. Okay? Just draw him real faint. Okay? And be ready to erase him. And every time he hits 0, asymptote. And every time he hits the top of his amplitude, now it's technically not an amplitude because this red part is actually where the graph is not. Okay? So when we graph sine, it is the anti-cosecant. But we use him to accomplish these graphs, okay? All right, hopefully that's good. And let's see, do we have, where are we at? Okay, we'll actually stop right there, and I think we'll do the last video here.